Number 1. Which of the following is a differential equation of first order? So when we say first order of differential equation, it only contains first derivative and does not have partial derivatives. And the only choice that fulfills this requirement is option C. So we have option C. Number 2, how can the following differential equation best be described? AD squared x over dt squared plus bt plus dx over dt plus c equals dt. A. Linear, homogeneous, and first order. Homogeneous and first order. Linear, second order, and non-homogeneous. And D. Linear, homogeneous, and second order. This differential equation contains a second derivative, therefore it is a second order differential equation. The forcing function is a non-zero, therefore it is a non-homogeneous. And all terms at the left side, all terms here, have a coefficient that are constant or a function of independent variable. In this part, it is independent variable t. Therefore, it is a linear differential equation. The answer is choice C, linear, second order, and a non-homogeneous. Letter C. Number 3, the differential equation given is correctly described by which of the following choices? AD squared y over dx squared plus bxy dy over dx equals to f of x. A. Linear second order non-homogeneous. B. Linear second order homogeneous. C. Nonlinear second order homogeneous. Or D. Nonlinear second order non-homogeneous. So, since this differential equation has second derivative, therefore, the differential equation is of second order. And since this term contains the dependent variable y, therefore, this equation is a nonlinear. And since the forcing function f of x is implied to be non-zero, the differential equation is a non-homogeneous. So, number 3, the differential equation given is correctly described by which of the following choices? AD squared y over dx squared plus bxy dy over dx equals to f of x. A. Linear second order non-homogeneous. B. Linear second order homogeneous. C. Nonlinear second order homogeneous. Or D. Nonlinear second order non-homogeneous. So, since this differential equation has second derivative, therefore, the differential equation is of second order. And since this term contains the dependent variable y, therefore, this equation is a nonlinear. And since the forcing function f of x is implied to be non-zero, the differential equation is a non-homogeneous. So, number 5. Write the differential equation of a straight line with a slope and y-intercept equal. So, from our equation of the line, y equals mx plus b. And in this problem, we have given a slope and a y-intercept equal. So, our graph for this is like this. A slope and y-intercept equal m equals b. So, we can substitute b as m in this equation. So, we have y equals mb, bx plus b. Factor out, we have bx plus 1. So, by differentiating this equation, we have dy equals b dx, and b therefore equals dy over dx. Substitute the value of b here. We have y equals b dy over dx x plus 1. So, cross multiply y dx equals x plus 1 dy. Transpose, we have y dx minus x plus 1 dy equals 0. So this is the differential equation of straight line, letter B. Number 6, what is the differential equation of the family of parabolas having their vertices all the origin and their foci at the x-axis? So we have a parabola having a vertex at the origin and a foci on the x-axis. So from the equation of parabolas, y squared equals positive negative 4ax, positive if opens to the right and negative if opens to the left. So multiply by x, we have positive negative 4a x over x. So y squared over x equals positive negative 4a. So differentiate, we have x 2y dy less y squared dx over x squared equals 0. So we have 2x dy less y dx equals 0. So this is the equation of family of parabolas having their vertices at the origin and their foci at the x-axis. Letter B. Number 7. What is the differential equation of a circle whose center is at origin? So we have a circle whose center is at the origin. So from the equation of circle, x squared plus y squared equals r squared. When the origin is at the center, by differentiating this, we have 2x dx plus 2y dy equals 0. So 2, we have x dx plus y dy equals to 0. So this is the equation of a circle having a center at the origin. Letter B. Number 9. Find the differential equation whose general solution is y equals c1x plus c2ex. So we have y equals c1x plus c2e raised to x. So y prime, therefore, c1 plus c2ex. Y double prime, we have c2e raised to x. So let's call it equation 1, equation 2, and equation 3. So substitute 3 in 1. 3 in equation 1, we have y double prime equals c2ex. So y equals c1x plus y double prime. So this is equation 4. Substitute 3 in 2, we have 3 in equation 2. Therefore, y prime equals c1, c2ex is y double prime. So plus y double prime. So from here, c1 is equal to y prime less y double prime. So substitute c1 in equation 4. So c1 in equation 4, we have y equals c1 y prime less y double prime x plus y double prime. So y equals, distribute x, we have x y prime less x y double prime. So plus y double prime. So factor out y double prime. So we have y equals x y prime less y double prime x plus 1. So transposed, we have y double prime x plus 1 minus xy prime plus y equals 0. So this is the answer. Letter A. Number 10. Solve the constant of the given differential equation x dx plus 6y raised to 5 dy equals 0, considering x is 0 and y is 2. So we have x dx plus 6y 5 dy equals 0 when x is 0 and y is 2. So integrate, we have x dx plus integral of 6y raised to 5 dy equals integral of 0. So we have x squared over 2 plus 6y raised to 6 over 6 equals c. So when x is 0 and the y is 2, we have 0 squared over 2 plus 6, 2 raised to 6 over 6 equals c. So we have, this is 0, we have c equals 2 raised to 6. So 2 raised to 6, we have 64. Constant. Letter B. Number 13. In the following differential equation, dx over dt plus 4x equals 0 has the initial condition x of 0 equals 12. What is the value of x of 2? So we have dx over dt plus 4x equals 0. So when x of 0 equals 12, find 4x of 2. So dx over dt plus 4x equals 0. Multiply both sides by dt over x so that dx over x equals transpose. We have negative 4 dt. Integrate plus 0. So we have ln of x equals ln of negative 40 plus ln of c. So e ln of x equals e ln of negative 40 times c. So x, therefore c times e raised to negative 40. So when x of 0 equals 12, t is 0 and x is 12, we have 12 equals c e negative 4 times 0. So this is 1, c equals 12. So when c is 12, then x of 2 unknown, t is 2, and c is 12. Therefore, substitute here. We have x equals c, 12 times e, negative 4 times 2. So x, therefore, we have x, therefore 12 alpha e raised to negative 4 times 2. 4.03 times 10 raised to negative 3. So 4.03 times 10 raised to negative 3. Answer letter B. Number 14. Find the general solution of sin x sin y dx plus cosine x cosine y dy equals 0. So we have sin x sin y dx plus cosine x cosine y dy equals 0. This is a variable separable differential equation. And so, multiply both sides by 1 over sin y cosine x. So we have sin x dx over cosine x plus cosine y dy over sin y equals 0. Transpose sin x dx. So we have cosine y dy over Sin y equals negative sin x dx over cosine x. So integrate. We have integral of cosine y dy is ln sin y. And the integral of negative sin x dx is ln cosine x plus ln of c. So we have e raised to ln of sin y equals to e ln of cosine x and times c. So sin y equals c cosine x. We have letter A. Number 15, solve the differential equation of x, y less 1 dx plus x plus 1 dy equals 0, considering that y equals 2 when x equals 1. Determine y when x equals 2. So we have x, y less 1 dx plus x plus 1 dy equals 0. So when y equals 2, x is 1, and when y unknown, determine y when x is 2. So we have x, y less 1 dx plus x plus 1 dy equals 0. Multiply both sides by 1 over y less 1, x plus 1. So we have dx, x dx over x plus 1 plus dy over y less 1 equals 0. So 1 less 1 over x plus 1 dx plus dy over y less 1 equals 0. So integrate. We have integral of dx minus integral of 1 over x plus 1 plus integral of dy over 1 less 1 equals integral of 0. So we have x minus ln of x plus 1 plus ln of y less 1 equals c. So when x is 1, y is 2, 1 less ln of 1 plus 1 plus ln of 2 less 1 equals c. So we have 1 less ln of 1 plus 1 plus ln of 2 minus 1, 1. So c is 0.3069. So when c is 0.3069, and x equals 2, substitute here from here to find the value of y. So we have 2 less ln of 2 plus 1 plus ln of y less 1 equals c, 0.3069. So we have the value of y dot. So we have 2 minus ln of 2 plus 1, 3 plus ln of y less 1 equals 0.3069. So we have y 1.55. Letter C. Number 16, find the general solution of the given differential equation. 2x less y dx less x plus 4y dy equals 0. So we have 2x less y dx less x plus 4y dy equals 0. So distribute, we have 2x dx less y dx less x dy less 4y dy equals 0. Combine this, we have 2x dx less x dy plus y dx less 4y dy equals 0. So integrate. We have 2x squared over 2 less, this is xy, less 4y squared over 2 equals c. So we have cancelled, this become 2. So x squared less xy less 2y squared equals c. Or we can rewrite as x squared less 2y squared less xy equals c. Letter B. Number 17, find the general solution of the given differential equation. 2x plus 3y dx plus 3x less y plus 5 dy equals 0. So we have 2x plus 3y dx plus 3x less y plus 5 dy equals 0. So distribute, we have 2x dx plus 3y dx plus 3x dy less y dy plus 5 dy equals 0. So we have factor out this, we have 2x dx plus 3 y dx plus x dy less y dy plus 5 dy equals 0. So integrate. We have 2x squared over 2 plus, this is xy, so 3xy less y squared over 2 plus 5y equals c. So multiply both sides by 2. We have 2x squared plus 6xy less y squared plus 10y equals c. So we have letter D. Number 20. Find the general solution of the given differential equation dx over dy plus 2 over yx equals to 5y squared. So we have dx over dy plus 2 over y x equals to 5y squared. This is a linear differential equation, linear in x. So we have dx over dy plus p of y x equals to q of y, wherein this is equals to x e raised to integral of p of y dy equals to integral of q of y multiplied to e integral of py dy plus c. So from this equation, we have p of y, that is 2 over y, and q of y, that is 5y squared. So let's find first integral of p of y dy. So we have integral of 2 over y dy. So we have integral of 2 over y dy is 2 ln of y. From that, we have ln of y squared. So raised to integral of p of y dy is y squared. So substituting here, we have x. Raised to integral of p of y dy is y squared equals to integral of q of y, we have 5y squared times this, we have y squared dy plus c. So x y squared equals to integral of 5y squared multiplied to y squared is 5y raised to 4th dy plus c. So from this, we have xy squared equals to integral of 5y raised to 4th dy is 5y raised to 5th over 5 plus c. So multiply both sides by 1 over y squared. So we have x, that is y raised to 5 over y squared plus c over y squared. So we have x equals to y cubed plus c over y squared. Letter A. Number 22. The complete solution to the differential equation dy over dt plus 2y equals 1 when y of 0 is 1 is, so we have dy over dt plus 2y equals 1 when y of 0 is 1. So as you can see that this is a linear differential equation of linear in y. So from dy over dt plus p of t y equals to q of t, we have y e raised to integral of pt dt equals to integral of q of t e pt dt dt plus c. So from this equation, we have p of t, that is 2, and q of t, that is 1. So to find the equation, we have to find first this. We have e pt dt. So integral of 2 dt, integral of 2 dt is 2t. So substitute here, we have y e to t equals to integral of 1 q times e to t dt plus c. So from that, we have y equals y times e to t equals integral of e to t is 1/2 e to t plus c. Multiply both sides by e negative 2t. So we have y equals 1/2 plus c e negative 2t. So from that, when y of 0 is 1, this means that y of t, so y here is 1 and t is 0. So substitute here, we have 1 equals to 1/2 plus c e negative 2 times 0. This is 1, so we have 1 equals to 1/2 plus c. So c is 1/2. So substitute this here. we have y equals 1/2 plus c 1/2 e raised to negative 2t. So this is the answer. Letter C. Number 24. It is known that y of x passes through the points 0, 2, and 1, 4. Solve for y of x if the second derivative is g squared y over dx squared equals 1. So, from that, we have given 2 points, and this makes easy to solve for y of x. Just satisfy the condition that when x is 0, y is 2. And when x is 1, y is 4. So, from the choices, in choice A, we have x squared plus 3x plus 2. So, when x is 0, we have 2. So, check. So, when x is 1, we have 6. So, choice A is not the equation we are looking for. So, in choice B, we have 1/2 x squared plus 3x plus 2. So, when x is 0, we have 2. So, correct? When x is 1, we have 4. So, y of x is y equals 1/2 x squared plus 3x plus 2. Letter B. To prove, let's try C and D. So, 1/2 multiplied to x squared minus 3x plus 2. So, when x is 0, we have y is negative 2. So, C is not the equation. So, in D, we have 1/2 x squared plus 3x minus 2. So, when x is 0, we have y is negative 2. So, the right answer is letter B. Y equals 1/2 x squared plus 3x plus 2.